Hey, so in our last video, we talked about limiting reactants, and we learned how to figure out which reactant was the limiting reactant. We also talked briefly about excess reactants, and we said that the excess reactant is the one that's not the limiting reactant, whereas the limiting reactant is going to get completely used up during a reaction. The excess reactant, there will be some left over. And so today we're going to talk about a little bit about excess reactants. We're going to learn how to figure out how much of the excess reactant is left over after a reaction, and that's our target, to be able to determine how much excess reactant is left over. So let's go ahead and let's take a look at that. Okay, let's have a little look at this example, and we'll talk about how to figure out how much of the excess reactant is left over. This is the same example as we saw in the last video. It said if I react 20 grams of carbon dioxide with 15 grams of lithium hydroxide, how much excess reactant will be left over? And here I have the chemical equation up here. Let me write down these numbers it gave me. It told me that I'm starting with 20 grams of carbon dioxide and 15 grams of lithium hydroxide. And it wants me to figure out how much of the excess reactant is left over. Okay, well, to figure that out, the first thing we're going to do is we're going to do one of our four fraction stoichiometry problems, just like we've been working on. Okay, but to figure out how much of the excess reactant is left over, I need to start my calculation with the limiting reactant. Okay, so the thing that I start with needs to be the limiting reactant. But here's the problem. I don't know which one's the limiting reactant. Okay, last time we learned how to figure out which one is the limiting reactant, and that's what we're going to have to do. We're going to have to do a four-step stoichiometry problem, figure out which one of these is the limiting reactant, and then we need to start our calculation with that one. Now, you remember, figuring out the limiting reactant, I'm just going to pick one to start with. If I happen to pick the limiting reactant to start with, that's great. If I don't happen to pick the limiting reactant to start with, then once I figure out which one is the limiting reactant, I'm going to have to start over. So let's take a look at this, and let's do our calculation. So I'm going to pick, to start with, the 20 grams of CO2. I don't know which one's the limiting reactant. I want to start the calculation with the limiting reactant, but I don't know which one it is. So I'm going to start with that one. I'm just going to pick. And maybe I pick good, and I don't have to do a calculation again. Maybe I don't pick good, and I have to do two calculations. We'll see. Okay. So I'm going to start with this one. I'm going to start with 20 grams of CO2 and put it over 1. Second fraction, we'll go to the periodic table, and we will add up CO2. And you can see the periodic table boxes there. Carbon and 2 oxygens should add up to 44 grams. I'm going to put that in the bottom. 44 grams of CO2. And of course, 1 mole of CO2 on the top. In my third fraction, I'm going to go up to the chemical equation for the coefficients. On the bottom, I want moles of CO2, which is going to be, let's see, there's no number there, so it'll be 1 mole. 1 mole of CO2. And in the top, I want the other reactant. The other reactant was LiOH. And you can see there's 2 moles of LiOH. Okay. In the fourth fraction there, we're going to go back to the periodic table. And now we're going to add up LiOH, and I don't remember what it comes out to. Lithium is about 7, oxygen is about 16, and hydrogen is 1. It comes out to 24 grams. So I'm going to put 24 grams here on the top. LiOH, and then of course 1 mole. And we'll see what that comes out to here. So we've got 20 times 2 times 24 divided by 44. And those are both 1. So I get about 22 grams of LiOH. Okay, now I ask myself, which one is the limiting reactant? So if I have, if I'm going to need 22 grams of lithium hydroxide, and I have 15, which one is the limiting reactant, right? Well, you see, I don't have enough. I only have 15. I don't have 22. So I don't have enough lithium hydroxide, which means that one is the limiting reactant. So I'm going to put a little box around it. That one's the limiting reactant. Okay. Now to figure out how much of the excess is left, I need to have started my calculation with the limiting reactant. Did I start my calculation with the limiting reactant? I did not. So now what I'm going to do is I'm going to start over because I need to start that calculation with the limiting reactant. Okay. So now I'm going to do it again, but I'm going to start with that limiting reactant. So I'm going to start with the 15 grams of lithium hydroxide. And in all honesty, if you do have to start over, it's not that tough because you've already got all the numbers, right? They just kind of go in the reverse order and upside down if you have to do it again. So here we go to the periodic table for LiOH, which I had right here. It's 24 grams of LiOH, and of course 1 mole of LiOH. And then to the chemical equation, which I've got those numbers right here, they're just going to be upside down. So I'm going to want the 2 moles of LiOH on the bottom and 1 mole of CO2 on the top. Okay. And then in the fourth fraction, we are going to go to the periodic table for carbon dioxide, which is right here. It's 44 grams. 44 grams of CO2 and of course 1 mole. So let's work this out. So kind of goes downward, okay. 15 times 44 divided by 24 divided by 2, and I get 13.75. So here we have 13.75 grams of CO2. Now the question asked, how much of the excess reactant is left over? If this one's the limiting reactant, this one's the excess reactant. I started with 20 grams. I used 13.75 grams. How much is left over? Well, that's easy. We just subtract. So we're going to do 20 grams minus 13.75 grams and see what we get. And that should be, what, 6.25? Use a calculator if you want. Grams, and that is of carbon dioxide. And that will be my answer. Will they all be this much work? No. About half the time, you'll guess right for the limiting reactant. You won't have to do a second calculation, right? So you'll do your calculation, figure out how much of that excess reactant was used, and then just subtract it away from what you started with. So that is how you figure out how much excess reactant will be left over. Okay, have a look at another example here. This one, I've actually planned this one out because on the last problem, we started with the excess reactant and had to start over. This time I've planned it out so that we're going to start with the limiting reactant and don't have to start over. And that way you'll see an example both possible ways, both ways that things could go down. So this problem, it says if 26 grams of silicon dioxide, SiO2, is combined with 47 grams of carbon, C, which is the limiting reactant and how much of the excess is left. Okay, so we're going to start here with the silicon dioxide, with the SiO2. So let's start with that. So we'll start with the 26 grams of SiO2. Then we'll go to the periodic table and we'll add up a silicon and 2 oxygens, SiO2. Silicon is about 28 and oxygen is 16, so they should add up to 60 grams of SiO2, and then of course 1 mole. Third step there, we'll go to the chemical equation and we'll put in the coefficients. So on the bottom I want moles of SiO2, and there's no number there, so it's 1. In the top we'll want moles of the other one, which is the carbon, and there are 3. In our fourth fraction, we'll go back to the periodic table, and now we're going for carbon. And if you look it up, it's about 12 grams. So we'll put 12 grams of carbon, and then of course 1 mole. And then we'll work it out here. So I've got 26 times 3 times 12 divided by 60. And there I get 15.6. So it's 15.6 grams of carbon. So now stop and ask yourself, which one is the limiting reactant? Okay. If I'm going to need 15.6 grams of carbon and I have 47, do I have enough? Yeah, I have way more than enough. I only need 15 and I have 47. I have way more than enough, which means that one's not the limiting reactant. It's the other one. So which one is the limiting reactant? SiO2. So then I asked myself, did I start my calculation with the limiting reactant, or do I have to start over? And you can see I started with the limiting reactant. So yay, I don't have to start over. Okay, so the question, how much excess is left over? Well, if I started with 47 and I used 15.6, how much is left over? Well, we'll just subtract. Minus 15.6. So I'm going to grab my calculator. I could probably do it in my head, but I'm too lazy. 47 minus 15.6, and I get 31.4. 31.4 grams, and that's carbon. So that's how much excess is left over. So you see, it's a lot. It looks like a lot less work when you pick the limiting reactant to start with. Of course, you've got a 50-50 shot at picking the limiting reactant to start with. You probably only do it about half the time, you know? Okay, so there you go. That is how we figure out how much of the excess reactant is left over. So now you can identify which one's the limiting reactant, which one's the excess reactant, and how much of the excess reactant is left over after the reaction. So hopefully that helps us be able to determine how much excess reactant is left over. Till next time, take it easy.